What if I told you that the secret to understanding profit isn't in some dense business textbook, but in the laws of classical physics? Yeah, you heard me right. Today, we're diving into a really powerful analogy that treats economic value just like physical energy, and it connects two fields you'd probably never ever expect to see in the same sentence. It sounds like the setup to a pretty weird joke, right? A spinning turbine and a supermarket checkout. What could they possibly have in common? Well, the answer reveals this surprisingly deep connection. It turns out the fundamental principles that govern motion and energy in physics have this stunning parallel in how markets create profit and value. I mean, on the surface, these two worlds couldn't look more different. You've got mechanics over here, which is all about physical forces, motion, and energy, and then you have economics, which is all about human choices, wants, and resources. But what if? What if the underlying logic behind them is exactly the same? So how do we build a bridge between these two? Well, it's actually built on a pretty simple fact. One of these sciences is much, much older and way more developed than the other one. And that's really the key here. The laws of mechanics, they've been battle-tested for centuries. We know they work. They're a solid, reliable foundation. So by borrowing this really robust framework, we can bring some much-needed clarity to the, let's face it, often messy and confusing world of economics. All right, so the heart of this entire analogy, it really boils down to one simple, elegant distinction that exists in both worlds. And that's the difference between things that are in motion, things that are flowing, and things that are just being stored. And this is where it all just clicks into place. Look at this. In physics, work is a flow of energy, right? Well, in economics, benefits are a flow of value that happens during a transaction. Now, on the flip side, energy can be stored, just like economic surplus, which is just another word for profit, is stored by a company. The mapping is almost one-to-one. It's incredible. So let's get into that. Think about pushing a heavy box across the room. The box doesn't contain work. The work is the actual act of energy flowing from you to the box, which makes it move. It's a transfer. It happens, and then it's over. And believe it or not, it's the exact same logic in economics. When you buy a coffee, you don't possess the benefit as some separate thing in your pocket. The benefit is the value that flows to you during that transaction. It's the economic equivalent of doing work. Okay, but we can get even more specific here because it gets better. In both physics and economics, not all these flows are created equal. Some of them can be captured and reused, while others, well, they kind of just disappear into the background. In physics, this is the classic difference between work and heat. The energy you use to lift a heavy weight, that's useful work. You could get that energy back by dropping the weight. But the energy that's lost as heat from friction, that just spreads out into the environment. And for all practical purposes, it's gone from the system. Now, let's apply that exact same idea to buying something. The profit a company makes, that's like useful work. It's a surplus that can be stored and reinvested to go out and create even more value. But the satisfaction you get as the consumer, that's like heat. Once you enjoy that coffee, the economic value is consumed. It's been converted into your personal well-being, and it is basically dissipated from the market system. You know, this brings a whole new meaning to that famous phrase, there's no such thing as a free lunch. For the value of that lunch to even exist for you, it has to be eaten. It has to be consumed. And in that very act of consumption, its economic value is converted into your satisfaction, and it dissipates from the market, just like heat radiating from a hot engine. Okay, so we've got flowing value and we've got stored value. You with me? Good, because now we're going to add another layer from physics, the difference between value that's actively moving around and value that's just waiting to be unleashed. In physics, this one's super straightforward. Kinetic energy is just the energy something has because it's moving. A car speeding down the highway has kinetic energy. A car parked in the driveway does not. Simple as that. So the economic parallel here is something we can call direct surplus. This is the profit that's being generated right now, today, from active buying and selling. It's economic value that is literally in motion. But what about the opposite of motion? Well, in physics, that's called potential energy. Just think about all that water held back by a giant dam. It's this immense power held in reserve, just sitting there, waiting for the gates to open so it can be released. And its economic counterpart? You guessed it, potential surplus. Think of a massive warehouse filled with products. That inventory isn't making active profit yet, but it contains a huge amount of stored value, potential profit that's ready to be converted into active, direct surplus the very second it gets sold. It's a coiled spring of value. So here we are. We have these incredible, almost perfect one-to-one parallels between mechanics and economics. But so what? Why does any of this actually matter? What's the big takeaway from all this? Well, it matters because this isn't just some clever party trick. It gives us a rigorous new lens to see the economy through. It takes the sometimes chaotic flow of the market and simplifies it into these basic terms: flows and storage, work and heat, kinetic and potential. It even lets us create economic laws with the same kind of precision as physics. Take the benefit surplus principle. It's basically the economic version of the work energy principle. All it says is that the flow of benefits into a system has to equal the change in its stored surplus. All of a sudden, the invisible forces of the market start to look a whole lot more like the predictable, understandable forces of the physical world. And that, of course, leaves us with a really fascinating question to chew on. If the laws of classical mechanics can so neatly describe profit and trade, what other physical principles might apply? What could the laws of thermodynamics, or hey, even quantum mechanics, tell us about the future of our economy? Now that is a powerful idea to think about.